Alright folks, we're going again. In this video we want to start a discussion on simultaneous equations, but not the regular simultaneous equations that we would have done before. The simultaneous equations we're looking at would be the one where we have one linear equation and one non-linear equation. Alright? This type of simultaneous equations that most people are familiar with. Anything up to form 4 for most people. Form 2, form 3, form 4 would be 2 linear equations. Normal stuff. You have the elimination method and you have the substitution method. Right? Of course, I would have introduced a hybrid method where you could mix elimination and substitution. We have videos on that in another place. Here now we have a linear and a non-linear. And the most important thing that I want to press home is that the methods that you would use for linear equations, where you have 2 equations as linear equations, you have to be very careful about transposing those methods into the scenario where you have one linear and one non-linear. Why do I say that? I say that simply because the elimination method is not applicable when you have a pair of simultaneous equations where one is linear and one is non-linear. Let me say it again. When you have a pair of simultaneous equations where one is linear and the other is non-linear, the elimination method is not applicable. Right? Do not try to solve a pair of simultaneous equations, linear and non-linear, using elimination. In that case, the only option that is available will be the option of substitution. You have to substitute something into another thing. Right? And the substitution works where you substitute from the linear into the quadratic. Right? So let me just do a quick schematic, because I know some people like to see little diagrams and things. So the first type that we are accustomed to would be linear and linear, right? We're comfortable with that. In that case, you have 2 methods of solution available in the conventional thing that we're doing so far. You have elimination, and then you have substitution. Right? What most people do is that they learn elimination alone. A lot of teachers only focus on elimination. That is where a lot of textbooks start. Elimination. And a lot of people stop here and then they try to take elimination into this. Can't work. Can't work at all. Right? If we have a different situation now, different scenario, where you have, let me take some space up in the corner here. Right, with my blue boy. Right, in my pocket. Right. So up in the corner here now, we have the other scenario where you have the linear simultaneous equation. Right? And you have a non-linear. Right? A non-linear simultaneous equations. Then in this case, you have only one option available, only one. And that option is substitution. Right? So do not try to use elimination if you have a pair of simultaneous equations where one is non-linear. Which then begs the question, how do you know when an equation is non-linear? Right? The easiest way to know is to look for a power of 2 or anything beyond. Right? At this level, you will usually get another equation with a square in it at some point. In other words, they're giving you a hint to allow you to recognize the equation as a non-linear equation. Right? You could also have a situation where you have 2 variables coming together in the same space. That too is a non-linear equation. So if, for example, I have if I have, let me use this equation as an example. If I have y is equal to 2x minus 5, that's a linear equation. If on the other hand I have xy is equal to 2x minus 5, that's a horse of a totally different color. So even though we don't have a square here, a square that you could see, keeping it simple for now, if you have two variables interacting in a multiplicative manner, either multiplying or dividing, then yeah, you're sure that is a nonlinear equation, right? I could also say, for example, I could say something like, I could say y over x is equal to 2x minus 5. You're sure that is not a linear equation, right? So in other words, you have to be very familiar with the equation of a straight line. You have to be able to recognize the equation of a straight line. You have to be able to recognize a linear equation, and then from that vantage point, anything that is different to that, you immediately start to look at as a nonlinear. And once you recognize that, then you come in here, not here, right? I cannot make that point more emphatically, because that is a very common mistake. Very, very common mistake. And I've taken some time in this video to talk about it, so that at least at the level of hearing what I say, we could drive the point home. And then, as is always the case, your job would then be to go and find questions and practice. Alright? That is your job. My job is to make it aware. Alright, so let me go through this one so that you could see the process in action, and then you will then be able to go and apply that to other equations. Yeah? So let me go. So you have a linear and nonlinear equation. The one on top here is the linear, and the one below is the nonlinear, right? In this case, you could clearly see that the second equation is a nonlinear equation, because they have squares. X squared plus y squared is equal to 10. There is no way that x squared plus y squared equals 10 is a linear equation. So immediately we know that elimination is not an option. So let me substitute. We substituting from the linear into the quadratic, right? Let me write it out, because I want to let you see it. Don't say you never see it. Right? When you're substituting from the linear into the quadratic. Right? How do we do that? We do that by choosing one variable here, making that the subject of the formula, and substituting into the equation. So in the first case, we already have the equation written as y is equal to 2x minus 5. So we make y the subject of the formula. It's done there already. So if you take the traditional approach of numbering the equations, you have this as equation 1, and you have this as equation 2. Then you could say from equation 1, you already know that y is equal to 2x minus 5. And then you say now, look the substitution here now. Substitute into equation 2, and we go in. So you have x squared plus brackets 2x minus 5 squared is equal to 10. So by going through these first two steps, you now convert these two equations into one single equation where you have one variable to find. The difference, however, is that because you have a nonlinear equation in the mix, you will have more than one solution for x and y. Alright? Now, for most situations, at most levels of maths, at secondary school and whatnot, you will have two values of x and two values of y. But in terms of the broader discussion, there's no rare, depending on the type of curve you're dealing with, there's no reason why you can have 3 values for x and 3 values for y. Or maybe 4 values of x and 4 values of y. But as a different type of curve, we leave that alone for now. I just throw it out there so that you can think about it. But generally speaking, in the school system, you would have 2 values of x and 2 values of y. Right? So, let me do the arithmetic now. And here now is where the other algebra would enter the picture. I'm not going to go into all those details here. I'm just going to run through the question. Alright? So here now, you have x squared plus 4x squared. 5 by 2 is 10 by 2 is minus 20. Minus 20x plus 25 is equal to 10. If you want to know how I move from here to here, yeah, that's a different topic, right? I would have done other videos on that, special expansions, right? But that's for another place, so we leave that alone for now. And then you just simplify. Let me see. We can rub this off and steal some space on this side of the board. Yeah? So we're saying x squared plus 4x squared is 5x squared. So that'll be 5x squared minus 20x. Yeah? Minus 20x plus 25 minus 10 is equal to 50. Right? Okay, let me leave it as plus 25 equal to 10. 15, sorry, not 50. So 5x squared minus 25x, you bring it across, plus 15 is equal to 0. And now that we have 0 on the right side, we could divide everything by 5 and say that x squared minus 5x plus 3 is equal to 0. Minus 20x. Sorry, my mistake here. You see? Mistake, man. Minus 20x. So it's 4x minus 4x. Right. X squared minus 4x. You factorize, you get x minus 1 into x minus 3. Again, I'm not going into the details of how we get that. You have other videos on that too. X minus 1 into x minus 3. So x equal 1 and y, sorry, and x equal 3. Again, that is for another video, right? But I'm writing it in a way where you could follow. And if you're not sure, you see some kind of logic and you could ask a question and then you could go somewhere else and double check and verify and come back. Right, and then having gotten the values of x, we then substitute into any of these two equations to get the corresponding values for y. So when x is equal to 1, we substitute into equation 1 and we get that y is equal to 2 by 1 minus 5 is equal to 2 minus 5 is equal to minus 3. And when x is equal to 3, we substitute here and we get that y is equal to 2 by 3 minus 5, which is equal to 6 minus 5, which is equal to 1. So when x is equal to 1, y is equal to minus 3. Right? Y is equal to minus 3. And when x is equal to 3, y is equal to 1. Right? So what I usually do is I tend to write the corresponding y values below the x values. That way you have a sense of order in your write-up so that you yourself could follow and anybody reading your paper could follow. Right? And with this now, you have 2 values of x and 2 values of y. Yeah? So that's basically it, you know. That is basically it. Alright? No, I'll leave that for another video. Alright? So I'm going to work the same question now, In a video following this time we're going to make x the subject of the formula, substitute, convert into an equation for y, and demonstrate that you'll get the same results. So in other words, it doesn't matter which variable you choose in the linear equation. General rule of practice, try and choose the easier one now. But I encourage you to look at the next video now so you can see the clear difference in difficulty between the y here and the x. And again, you could then factor that into your consciousness when you go to practice, when you go to develop a methodology to do these types of questions. So stay tuned.